Okay. Okay, again, thanks to all participants. I hope that yesterday training was useful for everybody. I see again, let me highlight difficulties in virtual trainings that are implicit in the type of training, but yeah, we are also expecting to do these trainings, to review these trainings together, hopefully in person. On one hand, on the other hand, I would suggest to all participants to interrupt Biniam whenever. I strongly suggest that everybody tries to do by themselves the exercises that Biniam is showing, and raise your hand whenever there is something that is not clear or that is not working. Feel free also to share your screen, whomever is trying to do the exercises himself and is not, for some reason, is not working. So feel free to raise your hand, and then at that point you can share your screen, and hopefully we can solve whatever problem you might face. I think hopefully this might work. Definitely depends also on you. So hopefully some of you will be willing to do this during the exercises. Other than that, again, let me sorry about my mistake in sharing the wrong link. So let me adjust the link, and I will paste here for the recordings in the chat. In the meantime, I'll leave the floor to Biniam so that you can go on. Maybe if I may suggest, you may want to do a little bit of a recap of what you have covered yesterday, and then start with the new topics.
Sure.
Thank you.
Okay, thank you, Paolo. Let me share my screen, and let's recap what we have done yesterday, and then go to the other part within the module, within the same module. Okay, so let me share my screen here.
Yes, while you're sharing, Benjamin, I'd like to convey the feedback from the participants yesterday. They appreciate the session yesterday, and particularly they could exercise some tutorials within the QGIS. So they appreciated your way for convening the information and the training itself. Thank you, Benjamin, for that.
Thank you very much, Muna, Dr. Muna. This is really very good for me to continue even today's session with passion. Thank you very much. Okay, so can you see my screen? Can you?
Yes, we can.
Yes, good. So even yesterday, if you remember, I was adding some other pointers on our lesson in the practical session. So I have added this here in the server here in QGIS folder. So you can, I hope you have got a new link to download even the recording. But in addition to that, I have added here additional materials of QGIS. So in addition to the training material that you got yesterday, I have added some more PDF files. So these are the kind of step-by-step instructions to work on vector properties dialog, like labeling, even a lesson on installing and managing plugins, and even how to extract by attribute, and with working with projection. So I've tried to compile from the guideline, and you can find it here. For example, if you see this with working with projection, if you open it, you can see that that about the projection, how to define on-fly projection, how to change the projection, how to custom the coordinate reference system in QGIS. And here, how to extract by attribute. If you remember, we opened an attribute and we've selected some records from the attribute and then export it to new shape file. So this is where we selected, if you remember, with some expression. So that might be difficult for you because you may need even to see the recording what we have done, so that these PDF files might be very helpful for you how to do each and every things that we have added yesterday. Let's for example, this lesson installing and managing plugins. We installed one plugin to see the Google satellite. So it is the same for all, so that you can find it how to find a new plugin in QGIS and how to install it and uninstall in your computer. And the other one is here selection. So if you remember, when we extract by attribute, we were using some operators, this field greater than this field or equals to this name and the like, so that this is also one part that you can use for your future work in QGIS. And the other one is about labeling. If you remember, we have used this buffer on texts, so that how can we do that and how can we change the label in QGIS in a shape file for the shape file in QGIS. So these materials or
sorry, maybe you are muted, Benyam.
Yes, Binyam, we are not hearing you.
Ah, really? Oh. Oh, I said, you know.
No, just the last few seconds. Just the last few seconds.
Okay, I think somebody muted me, but I did not make it. I think you have seen my screen.
Yeah.
Yeah. So, so these are the files, additional materials here. So you can find it here. You can download and work with them. Good. So these are the things to recap for yesterday's lesson. Let's open QGIS, all of us. So open QGIS. You have QGIS. It's an empty QGIS. You see the interface. So with untitled project, then to open a project, the existing project that you have done, for example, yesterday, you can use open button, or you can go to project open. So this is to open a project. Sometimes I see in my experience to add a layer like a shapefile or these things, people try to use this open button to add a layer here. So this is just to open a project, okay? To open a project with layers, existing project, okay? Existing project. So open it, and then you can see module 1, module 2A, module 2, and intro training, Biniam. So you can find this kind of file. So let's say Biniam, and you can open it. So you have this kind of data, this kind of interface with some layers. So this is to open a project, existing project. And to save it with a new project, you can use project save as. So this is a way to save it, okay? And here you have layers, point line, and polygon. Okay, point, lines, polygons here. So you can uncheck and check the layers in the layer panel here. And if you want to remove, you can remove it. Right click, remove layer, and you can add another one. Okay. So let's say now if we remove this era 5 precipitation, you can right click and remove layer, then remove legend entirely. Okay, you can remove it. If you don't want, and you can cancel it. Okay, so this is how to remove. And to add a layer, you have to go to open data source. So you don't have to go to project to add a layer. You have to go to this button, data source manager, or you have to go to layer and you can data source manager. So you can add data from here. So this is to add a data to QGIS interface. Okay, so vector, raster, mesh, point cloud, delimited text, whatever you need. So here vector. So let's have, for example, add a layer. Let's say the one we've done yesterday, or we saved as a new layer, is HMS Atbara catchment. Here, at the beginning, we have this HMS catchments for the whole area. But if you remember, using the attribute, we selected some layers. I mean, some records from the shapefile and saved it with a new shapefile. So if you remember, we did for Atbara and Barwa Kobosobat, and I gave you some exercise even to work with the white Nile, blue Nile, something. Yeah. So now let's open this shapefile, SHP. But if you see, always there is, it says all files, but you can choose Esri shapefile to open, and it will direct you to, or it will highlight the actual shapefile, the file itself, because shapefile has many files in it, including the database. Okay, including the database. So the one which is active is the one you are going to add it in in GIS environment. Okay, like in QGIS. So you can open, let's say, Atbara catchment, and open and add. Then you can see here Atbara catchment as a new layer. So you can zoom into that layer and you can see it. So this is how we can add a layer, a vector layer in a QGIS environment. Okay, this is for polygon. You can also add a point, a line, the same procedure. That's what we have done. And to change the symbology, we double click on it and then went to symbology and changed the color. Okay, changed the color like this, and click OK. Then you can change the color. And if you want to change the color of the sub catchments, actually you call them catchments, and that is the sub-basin, the Atbara sub-basin, and the catchments. So if you want to change based on the color, but based on the name of the catchments, then you have to choose, instead of a single symbol, you have to go to categorized, and you have to choose a field, the field to be classified, or to categorize it. Okay, so let's say with a name, then classify, and then you can classify with the name of catchments. Okay, with the name of catchments, and then click OK. Then you can see with different color. And this is another thing. Okay, symbology of a polygon. And if you want to label them, then the same procedure, or the same place that you can get label. That means you can double click on it, or right click properties. Either of the two are the options. Okay, so here you can come here, it's symbology, but you can go to label. So no labels. Normally it gives you no labels. Then you have to choose single label, and then with a name. And here it's a text. If you want to change the size, you have to be in text. Okay, here text formatting, buffer, mask, like that. But you have to go to text to change the size and the style. Okay, so let's say 14. Okay, and the size, if you want to make it bold, so like this, you can make it. Even the font name, or the font type, you can change the font type here, anything you want. Okay, and then the buffer, we have seen it. Okay, draw a text buffer, so with a kind of background in text. Okay, then if you click OK, and you can see with the label. So this is labeling, changing the symbol for a polygon. Even this is the same for pointers and the lines. Okay, there is it is the same. So that's all. To recap for yesterday's. If you have maybe any questions while you did some exercise on QGIS, please let's do it now. Okay, or please let me know. Have you had some kind of problem in yesterday's lesson? Any questions? Have you tried it in your computer? Have you played with it and have some problem?
They're all good QGIS users, Binyam. Thanks to your thanks to your to your training. Okay, just
yeah, I mean, I don't know. That's why, you know, I don't know about this their level of understanding. Huh?
No, yeah, really. Any feedback? Even I just saw some a comment on the chat. Everything, any feedback from you is really helpful at this stage. So feel free to write or to take a word here and say whatever you.
Giving time for them to if they have, you know, if they did some exercise and have some problem, and to answer and to before proceeding to the next one. If you don't have any question, good. Let's go on to the next part. Yeah. Okay. So now let's go to the next part with working with raster data. Okay, please open. You can open the or you can open a new QGIS. I think it is better to open a new one and click don't save it. If you want, you can save it, but if you don't, just click don't save it, just to keep the previous one as it is. So now here, you can, let's add raster data. So we had vector data, now raster data, raster. So you have to go to raster. So in the data source manager, you have to click raster. Before you choose or before you go to the folder to search a raster file, you have to click raster. That is a common mistake that people made normally. They click there in vector and then they try to search a raster file and have some problem. For example, if you want to open a raster file here, you and all files, always you can see all files. Then GIS here you can see raster 1 kilometer. Then you can, if you try to open it, then it will give you an error message. Okay, it will give you like this, an error message if you are in vector. So this is common mistake. So you have to be in a raster, then open it again. Huh? Open the file again. So this is the one you see, GT30E, the 020 and 40. So that is a raster data, one example of raster. So that means the data is with grids, okay, with grids instead of discrete files like a line, a point, and a polygon. It's a grid file, a number of pixels arranged in rows and columns. So you can add it here. So close it. So this is the digital elevation model data. So you can see it here for the whole East African and Arabian land. Okay, so you can see this is the elevation data. So it is, if you zoom into the place using zoom in, you can see pixels. Okay, so the thing is here, in case of this data, it is brighter. If it is brighter, that means it has a high value. If it is darker, it has low value. That is a common in a raster files. Okay, in raster files, if it is dark, that means low value, digital number value, and if it is brighter, that means it has high value. The value could be anything. Okay, could be elevation, could be reflectance. Even in modeling, you might have some values. We call them Z values. Okay, Z values. So the X and Y is a longitude, latitude, and the Z is any value, any value. So the brighter the color, the higher the value. Okay, the higher the value. So this is a raster image, and if you want to see the attribute here, it is with a scale, okay, from a certain lower value and very high value. So if you want to change the, let's say, the color, you can go to symbology and then change the color with it's a single band gray color. That's why you see a single band gray color. Single band gray color. But if you want to see it with some different colors, you can choose single band pseudo color, and with a minimum value and maximum value, you can see it here. So with kind of color ramp. So now if you see it here, red to blue color, so you have different kind of color ramps here. So you can change this one, like for example, spectral, it is spectral. And if you want to invert it, you can click invert the colors. Of course, you can choose any of the others, okay? So invert color ramp. So normally red color will be assigned for higher values to show or to make it a bit hotspot. So if you click OK, then you can see like this. It's like this. So you can zoom into the place, for example. I always drag to Ethiopia, so you can see the layer like this. So with the highest value have red color, the lowest values have blue color. So you can change the color like this for raster. Okay. Okay. So this is how to change the symbology of raster. But if you want to show, for example, if you want to add for the catchments, okay, or if you want to show the elevation for the catchments, you can add a vector layer. Let's say catchment. Okay, let's go to GIS and shapefile. Go to HMS, and you can choose HMS these catchments. Okay, then open. Or you can also, by the way, yesterday we have seen also to choose one, two or more files. Okay, so we can add 3 of those and then add it here. Yeah, and you can uncheck any you want, any layer you want. Now, if you see it here, you can see a polygon layer on top of the digital elevation model or raster. So we have to make it open. For example, here a symbol, a simple color. We have to use no brush, and then more transparent with some line as a boundary. Okay, so if you do like this, then you can easily visualize the digital elevation model with that of the catchment, So if you want, you can zoom into the place, let's say here, so you can see such kind of catchments. And with transparency with 100% transparency, almost, of course, when you say no brush, that means 100% transparent. So if you want to show for another kind of like sub-basin, then zoom into this place and you can change the layer color like this and no brush, and then change the line style or the color, the stroke color here, and okay. So you can see for HMS bus catchment. So you can label, for example, here, label, show label. So you can see for for each catchments, okay? This is for sub-basin called Baro Akobo Sobat, but for each sub-basins, I mean for each catchments. Okay, maybe let me give you some time to do this. Please open or add the raster data. This is GTOPO 30, the digital elevation model. Add it and change the color and pseudo color and change the color wrap in the inverted and add other polygons, sub-basins. The one is you saved, for example, as Blue Nile or Baro Akobo Sobat like this, and label it. So let me give you some time to exercise. If you have any questions, please let me know. Okay. There is one question that I've got from a chat box. Maybe let me give you this exercise with like 5 minutes, and then I will show you how to get this data from Earth Explorer, okay? And import it in QGIS. Import it in QGIS. Okay, Mohammed, Adil.
Hello.
Hello.
Can you hear me?
Yes.
Yeah. First of all, good morning, and thank you very much for the presentation. And actually, I have multiple questions regarding the first one regarding the digital elevation models for hydrological applications from your experience. So which one is the most appropriate for the hydrological applications? I mean, in terms of the vertical accuracy and also there is no distractions in the dims and so on. So in terms of this one, which one is the most appropriate from your experience? And secondly, regarding this training session, so that are not we going to do like some hands-on exercises on the delineation using QGIS? Actually, I'm mostly familiar with ArcGIS and also with QGIS, but not for the hydrological application. I have used it multiple times, and I remember that at that time we have to integrate TAUDIM with a QGIS to do the hydrological delineations and so on. So is it until now so that we need also TAUDIM to handle the hydrological delineation, or there are some available plugins that became handling the hydrological applications? And thank you.
So thank you, Mohammed. I think it is better to forward your questions because it is related to your professional hydrology.
Yeah,
So,
Biniam, I can handle this very quickly. Yes. But you're basically anticipating some questions that are not entirely QGIS related, but yeah. Anyway, really interesting and good question, especially in the light of the project that we are developing. So let me give you a quick answer now, but again, in other trainings, we'll cover this more deeply. So in terms of your question about which DTMs, which DEM are more suitable for hydrological applications, the question is, it depends. Let's say that for such a regional project that we are carrying out, that is covering most of the Nile basin, I mean all the Eastern Nile basin, we are relying on COP30 DTM, which is developed by Copernicus, which means satellite, which means the European Spatial Agency. We made a few tests on both the most famous available DTMs. I mean the SRTM and the COP30, and at least in the Nile Basin region, the COP30 proved to be way more detailed. Although the resolution, the spatial resolution is the same, which is 30 meters, the detail of COP30 DTM is much bigger compared to the SRTM, which mainly probably is, at least in this area, might be a resampling of the 90 meters original resolution. So we strongly suggest you to rely on the COP30 DTM. When you need to do more detailed analysis, not hydrological but hydraulic analysis, you may want to rely on more detailed DTM, which usually are not free. But for hydrological, any hydrological assessment, which means some basin catchment delineation, slopes analysis, and rivers extractions, those kind of applications, COP30 DTM is pretty much well enough, and this is what we are relying on. As far as your second question, I'm glad to hear that you are also experiencing ArcGIS and that now you are also learning QGIS. Yeah, me as well. I started with ArcGIS, and there was like a couple of applications that were used for hydrological catchments and rivers definitions. QGIS has some plugin, and there's also some functions that are embedded in the tool, but I would say they are not as easy as other tools have. I mean, specifically for this project, we are developing a HEC HMS model, hydrological model. And so we are using its internal GIS pre-processing and post-processing to define catchments, rivers, flow, slopes, sorry, and so on and so forth. So there are also functions within QGIS, but those developed by specifically inside HEC HMS are quicker and easy to use, especially in view of developing a hydrological model with HEC HMS. And the same with the other tool that we are using, which is SWOT. SWOT has its own GIS module, which is actually embedded, which is actually coupled with GIS, and it's called QSWOT. So in the training that are called HEC HMS and SWOT, so there are two different trainings that are coming next month, I guess. We will focus on those two tools and on the GIS modules that are used to perform hydrological application. All this that I just mentioned about the DTM and also about the HMS processing, it's well explained in the inception report. Sorry, in the report, the inception report, and also in the last report delivered to intro. But I will anyway share here in the chat a couple of links for your reference. I hope this answers to your question.
Thank you very much.
Okay, thank you, Paolo. So let me. I hope others were exercising on while you were explaining about his question. So now let's see. Please show us how we can get data from open data source like Earth Explorer. So you have to go to Earth Explorer here. Earth Explorer. So you can type there, and you can see this is a place where to get data. So you have to log into to this Earth Explorer. So now, if you see here, I'm already logged in because I'm using it frequently. So you can you have to register. It requires some information, basic information. So you have to feed that, and then you will be a member of that to download data. So you can see it here as data sets. So in the data set search, you can type, for example, GTOPO 30. This GTOPO 30 normally it is a 1 kilometer elevation model data. So 1 kilometer. So you can read more about it. So that's the one I tried to show you about raster in QGIS. So this is the USGS EROS archive digital elevation global 30 arc-second elevation. And this COP30 and other SRTM data, I think Paolo will share you the links. Of course, you can find it here. There is a possibility, but already he mentioned that. So this is GTOPO 30. So it is a global coverage with 30 arc seconds, approximately 1 kilometer. Okay, approximately 1 kilometer. So you have to go to the place. You have to check in first here. I mean, you have to check this box here in the data sets. Of course, you can get other even data here from different sources. Okay, land cover data, Earth observation data, even land satellite image data like that. So this is Earth Explorer. So you can zoom into the place you want to download, and let's say here. So you can see it here. So you can choose, for example, to add additional criteria, search criteria with this. Here you can see show maps, use maps. So it selects the whole area. When you zoom out, that means it automatically gives you some rectangular shaded rectangle. So you may change the place like this. So for example, you see, so you can change the map, the coordinates, by dragging the coordinates, the left, the upper left, the lower left, the upper right, like that. So you can choose like this, and then you have to click results. So GTOPO 30, then it will give you this result, and you you can click how it covers. Okay, so it covers all this area. Okay, it covers all this area, and you can see the footprint and how it looks there as well. Then this button is the one that you that takes you to download the data. Okay, so this is a download option. So downloading. So here you can see GeoTIFF and DEM. Okay, DEM and GeoTIFF. This is a bit bigger in size. So to open it in any kind of software, okay, and then you can download the GeoTIFF. Then automatically you'll get it in your computer. So this is how you can get data, for example, the elevation model with lower resolution. Of course, SRTM is has 30 meter, 90 meter resolution. This COP30 30 meter, and even there is Aster with 30 meter resolutions. There are variety of elevation models, even ALOS Pulsar with 12.5 meter spatial resolution. Of course, that is a product of SRT. They resampled to high resolution image, and then available to the public or to the users. So these are different sources of elevation models, but here I showed to you because depending on the size it's easier to use it for very basic QGIS training. That's why I used this one, okay? GeoTIFF, GTOPOS 30 with GeoTIFF data. So you can see that it is downloading, then you can use it in QGIS. So that is a data here, you see the one I downloaded from Earth Explorer. I hope I answered your question. Yeah, I think Paulo already sent you a link for COP30 DTM and another link for the same data. And another thing, good morning, please show us how prepare the DM and shapefile to projected data system for being process. I think I don't get your point. Can you maybe explain, Ahmed Ibrahim? Maybe let me give you a chance to explain here. Please show us how prepare the DM. Prepare the DM. We download the DM actually, and the shapefile to projected data system. Projected data. Ahmed, can you explain maybe your question a little bit to? By the way, you cannot prepare, it is possible to generate a DM, especially for topographic maps, like digitizing contours, and then you can produce elevation model data from a scanned map or from topographic, existing topographic maps, or you can generate from photographs, aerial photographs. Or you can capture from the satellite sensors, okay, in using a sensor, a microwave sensor. And with the shapefile to projected data system for being processed, maybe if your question is related to the projection system to your analysis, it has to be the same coordinate system for further analysis. But for visualization in QGIS, there is on-fly projection normally, so that we can see them together. For example, here, this data, the basin, sub-basin data, and the DM, they have a different projection system. That one is a global with GCS, but this one is with UTM. But you can see them together because there is always on-fly projection on QGIS, so you can see them together. You can see them together. Okay, you wrote again. Okay, I mean how to convert to the projection of the data from coordinate system. Okay, so this is what we have seen yesterday, how to project, how to change the projection of a shapefile. Okay, how to change the projection of a shapefile. So you can go to this processing toolbox, or this, if you don't have this processing toolbox, you have to go to processing and to this toolbox. And then here, project. So project. So you can see many tools here. Recent use drop, reproject, create style database here, reproject. So you can see reproject layer. So you can reproject a layer for example, for this catchment. So you can give an input here. Let's say this BAS catchment, and the target coordinate reference system would be this one. So you can easily project it. If you run it, then you will have a reprojected file of the sub-basin. So this is reprojected. If you see such kind of sign in the layer, that means it is temporary. You can see temporary scratch layer only. That means if you don't save it, then you will lose it. You will lose it. So that it is better always to save it. But if it's just for trying, for the sake of like whether the tool is working or not, then you can remove it from here. So it will give you a one-step chance to save it or not to save it in your hard disk. So you can remove it, for example. This is reprojected. If you see the projection, then you can see it now with this WGS84, okay, with lat long. But it's the same here with the elevation model. And then you can change the color and everything and the likes. Then you can do whatever you need to do on this. I hope it is clear. Any other question? Ahmed, is that okay? Or you still have some? Dr. Nahid. Please. So he just shared some screen like this. I hope he will explain. Let me give you a chance to speak, Dr. Nahid. So I opened what he shared. Marnat, we'll do just immediately after this one, okay? Can we do the mapping of the areas? Yes, there is. We do that. We can do that. But now, immediately after this session, after maybe 5 or 10 minutes, we will start. Zarihan. Okay. This is for today's. It's a reminder. Okay. Dr. Nahid. Maybe let me guess your question.
Good
Please.
morning, everybody.
Yes.
Good morning.
Good morning.
Thank you very much, Dr. Binyam, for the illustration. And I didn't manage to change the symbology. Maybe the version is not compatible with you, but I shared my screen. So you can give us some hint how we can move on. I tried it many times, but I didn't manage to change the symbology here.
Okay, good. That's what I guessed actually. Let me show you. Okay.
Oh, thank you.
So here,
Thank you.
yeah. So for example, it was like this single band. Okay. So it was like this. So when you download and open it in QGIS, it would be just like this one. Okay. So that's what I explained. But if you want to change the color, you have to double click on it, and then this is render type. So you have to be here in a render type. So Click on it and choose single band pseudo color. Single band pseudo color. Single band pseudo color. Single band pseudo color. By default, it will give you this color ramp with the minimum and maximum values. But if you see it here, it gives a color red for the lower value, very low value, and blue for very high value. But you have to, you have a possibility to invert the color as well. Invert the color. So you have a possibility to invert the color. Invert the color. Invert the color. Then okay. So you can see like this. Okay, this is actually the original. I tried many times to invert it, so it should be like this. It should be like this. I hope you got this one. Invert the color. Something additional here. You can go to transparent.
I think it didn't work out. Sorry.
Ah, really?
It worked out. Can you check? I sent the screen so you can see what is.
I think there is no problem on. Yeah, it says single band gray, and that should be changed to pseudo color. This one, somewhere here in single band gray. So this is your screen.
I sent the other one with pseudo gray. You can look at the chat. You'll find it below. It is pseudo.
Band pseudo color. Okay. So minimum, maximum. The value is different. This cumulative count here, the minimum and maximum is the same. Band one, the whole raster. Okay, let me do it again in my computer. How about others? Huh? I think you have to have this. It is the same. Okay, the same. And don't you have the color ramp? Color ramp. Check the color ramp. Is there any color ramp? Color ramp. Be in color ramp. Okay, that is the problem. I think there is no any color ramp here in your screen. Huh? There is no any color ramp. So please choose. Please choose there. This kind of color ramp. Okay, which is a spectral. If you
Sorry,
make
it is not there. Sorry, it is not there.
There is no option.
Yeah.
There is no option for color ramp. Oh, that's weird. Okay. Color ramp. Level unit, level
precision. Finally, I find it. I find it.
Where is it? In the color ramp or somewhere else? Let's not. I think it's good to know for all of us. It's good to know that. Where did you get it, or how did you solve it?
Yeah, Dr. Nahid, he's waiting for your answer. From where did you get that missing information?
No, I think she said that I found it. Huh?
Yes, yes.
Yeah.
She solved the problem, but I think you want to know how she solved it.
what I suggested to her here is that to choose a color ramp. I hope she...
Yes, I sent the screenshot so that you can see the whole picture. The last one, I find the color there.
You found the color ramp somewhere here, right?
Yeah.
Yes.
Yes.
That's
you can see it in the screen. You can see it in the screen.
Yeah. Yeah. Good. So now it's solved, right?
Thank you. Yeah, thank you. Thank you very much. Thank you.
Yeah. Okay. Any other question? Well, okay. There is also other things in symbology of this raster data. Here in the symbology, there is also another option like hillshade, contours. Hillshade is it will give you actually for visualization here. So with the sun angle, so you can see a kind of the hills from the digital elevation model. So you can see like this, which place has a highest and which place has lowest. So this is hillshade, okay? And some contours with some interval, it can also generate. So let's make it, for example, with 1000 here contour interval, and then click OK. So you can see a contour interval with 1000 meter, okay? So based on this, just symbology within the symbology or render type, okay? You can go back to single pseudo color and then change to the previous color scheme, okay? So like this, so you can come to this place. And even here, if you want to change the transparency, especially if you are trying to show, let's say you have this data, you have this sub-basin, but without changing the color of the sub-basin. If you want to keep it as it is and show the elevation model on top of it, then you can drag it to down here. It's not visible, but you can change the transparency of the raster data. Transparency. If you see it here, it has global opacity with 100%. With 100%, and you can decrease the opacity. So that means you are increasing the transparency in the meantime. Then if you click OK, let's say make it 60%, or you can type it here 60%, okay, 60%. Then like this, and then OK. That means you can see now the basin plus the elevation model or any raster on top of it, okay, on top of it. So this is how to change the transparency of raster data. Try to exercise this, changing the transparency. Changing the transparency. So you have to go to the raster data and transparency. Instead of symbology, you have to go to transparency and then change the slide here. The slide of opacity. Or you can type here the percentage of opacity, 50%. So you can see like this, okay? So please save this file with a name called module 2 raster in GIS folder, module 2 raster. So save this QGIS file, okay, QGIS project. So I saved it with module 2 raster and save it. So always it is better to save in a project, to reopen it again as it is, okay, with the same color, with the same symbology, with the same layers, number of layers. Of course, we are not saving the actual file, shape file or elevation model. Rather, we save the working environment, okay, working environment as a project. So we call it QGIS project. In ArcGIS or in ArcMap, it's called ArcMap file, MXT file with some layers. But here it's called QGIS project. It's a project. Any question? This is, for example, for Atbara with some transparency, I hope this is clear. So now, if you don't have any question, I will go directly to the next module, which is map production in QGIS. Okay, in QGIS. So here in this working with DEM and map production in QGIS. Okay, in QGIS here in this module, we'll try to produce maps. So we have tried to exercise on vector data, raster data, like a shape file and TIFF file, GeoTIFF files, and some exercise on those. Now, in creating the maps, there is what we call in cartography. Actually, in cartography, there is elements of maps. There are elements of maps. So the elements of the maps, like title of the map, legend, north arrow, scale bar, graticules, or we call them grids. These are normally the basic ones, but you can also add acknowledgements, some information on the map, okay? So we'll try to see how to create a basic map in QGIS. So let's use the previous file. So save this one and open the existing intro training QGZ file. So open this one, intro training.qgz. So the original QGZ file. So open that. So we will work with this one, with this. Okay, with this. Save the previous one and open this for us to work on mapping. If you have some difficulties, please let me know. Okay, one question, Ahmed Ibrahim asked this question, how to extract contours from the dam for a certain catchment and show in the map. So in QGIS, here you have to search in the processing contour. Okay, you can see there are many tools from different sources, from GDAL, from GRASS. Okay, so you can see contour, raster extraction contour. So this tool takes you, or from GRASS R contour will takes you, or will give you a contour from raster. Okay, so here this is, we don't have this raster. Let's open the previous one. Okay, open.
Who minimize as a definitely in who be jigo they will be sure with that. These are people.
Pardon, is it
Unsabotage or can be.
Is it for me?
No, I think it is by mistake.
No, yeah, okay. So let's see module to raster. So here we have this. So we have raster here, and then contour. We can type here contour. So you can generate contour from raster, from actually from elevation model. Raster is a general term for every image data. So R contour and contour, they are tools that you can find in QGIS from either from GRASS or GDAL. Okay, so this is a elevation model, and then you have to list of contour level. It's an optional, but here basic part is you have to set here the contour level. Okay, increment between contour levels. Let's say 1000. Let's make it 500, and let's run it. Then it will run, and then you will get a file in the form of line. Okay, you will get a file in the form of line. So there is some topological error. We call it topological error, but let's see what will happen. But this is a tool, by the way. This is a tool to generate contour from elevation model. Okay, elevation model. It has some error and didn't give us some contour lines. Let's try with this one. So let's try with this 500. There is some topological errors that I've seen in the data. So elevation. Okay, now I hope this will work. So these are the two tools that you may find in QGIS. But even QGIS, by the way, here in QGIS, you may even get some other software integrated to QGIS. Let's say Saga, this GRASS. These are open source GIS softwares, but integrated to QGIS. So even in, you can see here Saga contour line. So that's also to generate contour. So you see here now we got contour lines with 500-meter interval for this area. Okay. Okay, it's a line. It is now temporarily saved in your memory, but you can export it. Export, save feature as. So this is a shape file, and you have to be in your working directory. And here you can save it like contour 500 meter. Then save, then okay. Then I saved it to a permanent location. So I can remove the temporary file and okay. Now I have it here. So I can use it for mapping as well. For mapping. I hope it is clear. Huh? It is clear. Okay. Another question Ahmed asked. Okay, maybe it's before that. There is another question from Zarihon. Dr. Zarihon, first you have to extract or clip the DM for the catchment, and then you can generate contour for it. Yes, possible. That's also possible. That's also possible. Okay, you can extract based on the catchment, and then you can generate the contour for it. Yeah. And also you can even, after generating the contour lines, then you can also use a catchment, and you can clip for this sub-basin, for example. That tool is clip, okay? That is a tool, it's called clip. So for example, for vector, will be easier so that you can use the input layer contour and overlay layer for Atbara, and then you can run it, then close, and you can see, or you can zoom into the place, and you can uncheck the contour 500, and you can see the contour only for a certain sub-basin. So the same for the whole basins, for the 5 basins you can clip, and then also with the sub-basin, and for the catchment you can go on like that. Okay, you can go on like that. But this is a tool to clip that one. And the other question is, thank you. If I want to extract and present land use land cover for certain catchment. Now another story which is related to land use land cover. In the first place, there are products of land use land cover produced by different organizations and agencies. So depending on the time period you want. So if you want with in 2020 or 2000 or 2003 or whatever, there are products from different places. So you can search the available land use land cover from different sources. But for a certain catchment, if you want to do land use land cover for a certain catchment, it is by itself, it is a process, which is, we call it remote sensing. So it is a remote sensing processing, digital image processing, and you have to use a satellite image, or you have to use some kind of indexes for land use land cover. Nowadays, I can answer like this, okay? Nowadays, we use Google Earth Engine for producing very high quality land use land cover in terms of accuracy, okay? In terms of accuracy. And even the algorithms are quite many and quite vast. So based on even algorithms, you will get different product of land use land cover with different kind of accuracies, okay? So you can present, of course, land use land cover for a certain catchment, but by itself it is a big work, a big job to work on that. But you can use a freely available land use land cover, and then use it for your analysis. if that is enough. Okay, so you can find it even from here as Explorer. Okay, under the data sets, you can see land cover. Okay, you can see land cover here in Earth Explorer. So land cover. So this is, for example, a global land cover characterization. So this is GLCC. So, but from satellite image, from Landsat, you can also produce your own land use land cover for a catchment. And even for vegetation monitoring, you can use this NDVI or other vegetation indices as an input for land use land cover. But there are products already available here. You see land cover, annual NLCD C1 land cover. You can search what it is, and then it will give you some additional information. This is a cover product, represents predominantly state of the surface within the mapping here with respect to these natural anthropogenic surface covers. So you see, with some kind of standard, okay, with some kind of standard you can find. So these are some available land cover, not only here, but also you can see other sources, okay, other sources. One place, maybe the well-known place, is this RCMRD geoportal. This is really common for all of us. I usually go to this geoportal, this regional center mapping of resources for development. So many countries, I think all of us are here, okay? So you can see it here, data sets. So you can find some data from here, and you can even search the land use land cover, okay, for different countries in East Africa, okay, East Africa especially. So this is a good source to download land use land cover data. So here, even not only land use land cover, even land degradation data. So it is a bit slow because this geoportal has some data, heavy data. Maybe let me search by a keyword with land use land cover. So here, data sets, let's say vector or raster, you can type it land, let's say now Ethiopia. So you can search. Even with region here, you can choose any. So this is one source of getting land use land cover data. So you can see this is Ethiopia land degradation map and some boundaries, you see, and Tanzania land cover. Let's say, for example, Tanzania land cover. So you can get from here. Okay, this is another source. Okay, so there are other possibilities. Of course, you can produce your own and overlay with the catchment and do so your further analysis, especially for your hydrology. Okay, I hope I answered your questions. Anything else? Good. So now let's open the previous file, the original file here, intro training.qgz, and open this, and we have this one. We will try to use this for mapping purpose, okay, for mapping purpose. Open this one. So to create a layout that we call layout, okay, in ArcGIS, for example, here you have to have new print layout. So project, new print layout. That is a place where you can produce your map or create your map in QGIS. New print layout, okay, new print layout, new print layout. And immediately it will give you a box or a kind of a window with a box, okay, to enter a unique print layout title. So here, maybe let's say intro 1 map, okay, so let's say intro 1. So intro 1, then click OK. Then you will get such kind of interface. All of you must get this interface, okay? This one, intro 1. This one, okay? This one with some menus, with a new menus, with the new buttons, the new button. With a new button, like say here, it's different, print layout or to export the image and the likes. And here, move item content, move item, and some edit nodes and add map, add 3D map. Here, if you want to add image or picture, and to add some labels or text, to add some legend, and to add scale bar, to add north arrow, and some other tools for the mapping purpose, So when you look at this one, when you look at the data, if you want to create a map of this, you have to choose a print layout, okay? The print layout, okay? The print layout, okay? So it is now, if you see it, what kind of layout you see here? Can you type it here? It is? What kind of layout? The one we have. Is it landscape or portrait? That's the question, actually. This is a landscape. This landscape. So we can change the landscape to portrait and the likes. Before we do, we have. When Daniel told me, he said that he will do it. Okay, before we continue, we have to add the layer that we are going to create a map. So use this add map. Use this add map on it like this. Then you can see like this, okay? So immediately after you add the map, you will get some options to choose. So main properties, layers, extents, even some grids, overviews, some positions and size, okay? Rotation, frame, background, item, rendering, variable. So these are the main properties, okay? You can see main properties, it's related to scale, These layers related to the layers, and extent related to the extent of the map, okay? The map. So now, if you see this one, then the scale is different. So it says 24 million something. So we can change it to, let's say, 20 million, okay? 20 million. 120 million, 10 left. Then immediately when you click here or when you click enter, it will update the scale. It will update the scale. It will update the scale. So this is a place where you change the scale of the map, to change the scale of the map. Or let's make it 18, then enter. So even dragging this will change the scale. Dragging this one towards here, or towards here, or towards like this. It changes the scale, changes the scale, changes the scale. So to start with, just let's make it 18 million scale, 18 million scale, and let's have this one. Okay, let's have this as it is, okay, as it is, without adding any other elements, okay, without adding any other elements as it is, with 18 million scale. Okay. So when you click this, the outside button, then you can see the page size with A4. So if you want to change, you have to click on the white portion. If you click here, that means you will get the main properties of the map. But if you click here, you will get a property for the paper itself, the paper itself. So for the paper, the size, if you are really good enough with this size, that's the question that you have to answer. Let's say now you can change the paper size, either A6, A5, A4, A3, A2, which paper size you really want to print this map, So if you are going to present it or to plot it in a big size, then you have to choose, let's say A0. So it will convert it to A0. So when you click the map, then you'll see there, but the paper size is A0. And the orientation is portrait. So you can change the portrait, okay? You can change to the portrait. Now you can see it. You have a hello. Can you hear me? I lost power, that's why now I just reconnected.
We can hear you. We can hear you.
Okay, great. Now I reconnected with other source. Okay, good. Now here. Now let's make it A3 for this exercise, because to see it here, you can resize it. Okay, you can resize like this with A3 paper size, make it A3 and portrait, make it portrait. Okay, so A3 portrait, A3 portrait. It has to be like this. Yeah, for this first exercise. Okay, portrait. So when you click here, because I dragged it and to fill the whole area of the paper, and the scale is the same. Now, to cover the whole area of this A3 paper, I have to increase the scale. I mean, I have to make it large scale. Okay, let's make it 12 million, and then let's see what will happen. So it is processing, because now it is fetching even the background image to make it with 12 million scale. Yeah, now you can see it with 12 million scale. Still I have a chance to increase the scale to larger scale. Let's keep 10 million scale. So all of you, please make it 10 million scale, and as it is like this, okay? So the size is A3, portrait, A3, portrait, and 10 million scale. A3, portrait, and 10 million scale. A3, just to change the paper size, you have to be on the paper, okay? You have to click on it, A3, portrait. But if you want to change the scale, you have to be on the map and then change the scale. So that is really important before we go in detail about the elements of the map, okay? And then if you want to export this one as it is, if you want to export this map as it is, you can have a chance to export to image and to SVG and to PDF, So let's say to PDF, okay, to PDF, then you can export it and you can use intro one map. Okay, intro one, map one. You can save it as PDF. So you have an option and you can save it, okay? So as it is without changing the default options, okay? So you can see this PDF, or you can export it as image. Hopefully you will get the same like this. Okay, you'll get this one as JPG for a report purpose, for example. And PDF is already there, and in PDF, okay, in PDF. Yeah, so this is the product, okay. In PDF. In PDF. Okay. So this is a PDF, and the other one is in JPG. Please try to exercise this for the next 5 minutes, and you can share us to the, I don't know, to the chat box like the previous one, a screenshot at least, the PDF and JPG of your first map, actually without any elements, okay? With a 10,000 to 10 million scale, portrait and A3. and S3. Please share us here in the chat box. I don't know here. I can at least attach. Do I have a chance to attach, Paulo, here, or do I have a privilege to attach?
I guess so. Let us check.
Yeah. Here. Ah. Maybe let me copy and paste it. Huh? Yeah.
Yeah, it works. So, okay.
Yeah. So you can share us like this. What you have done with S3, 10 million scale and portrait. With S3. So to get this size, you have to click the paper. But to change the scale, you have to click the map. Okay, you have to click the map. To get the map, you have to use this add map button in the layout. And you can save this one. You can save it. If you close it, now it's gone, but you can open the layout because it is saved as intro one. So you can open it. There is a possibility to open a saved layout. So you have to go to project and layouts, and then if you click intro one, then you will get what you've saved. Now it is under the project. It is not saved somewhere in your folder or somewhere else, but it is under the project, okay, under the QGIS project. Just copy and paste the file that you exported. Huh? So 5 minutes. Okay. I think one person shared us the result, which is okay. Maybe the problem is here a scale. Scale is not the same with 10 million. There might be, you have to change the scale, like say 10 million. And to fill the whole area of A3 paper, it looks like A3. And the data you have, especially the sub-basins are now on top right corner rather than in the center. So you have to fit to the screen to this shape rather than the DM. So you have to zoom into to the basin, sub-basins rather than the DM. Okay, that is the main problem that I see from this one, but it is very good. And thank you, Vitadele. Okay, I think if there is no any other person who can share us, let's stop. And can you hear me?
Yes, very well.
Yes. Good. So let's stop here. Muna, maybe you can conclude and we will come back after an hour.
Yes, thank you, Benjamin. We will stop for 1 hour and come. If the person want to leave, it's okay. Otherwise, you can just stay connected. Thank you so much and see you after 1 hour.
Okay, see you.
Okay, see you later.